Okay, so hey everyone, this is the week 9 math quiz. So let's start with question 1. Given f of x is 2x plus 1, g of x is x squared plus 3, and h of x is 3 to the power of x. Now for this question, you will need a calculator because this one, h of x, you're going to be dealing with exponents. And obviously, you're not going to figure this out without a calculator. And keep in mind, calculators are allowed for this exam. So part A, f of 10. So what you're going to want to do is you're going to substitute, you're going to want to find f of 10 first. So substitute 10 in f of x and get 21. 2 times 10, 20 plus 1, 21. Now you're going to substitute the value you got, which in this case is 21, into your original equation. You're going to substitute it again into f of x. So f of 21 is equal to 2 times 21, which is 42, plus 1, which is 43. Now, part B, g 3x plus 1. Okay. Substitute 3x plus 1 into this function here, g of x. So substitute 3x plus 1 into this x, 3x plus 1 squared plus 3. Expand 3x plus 1 by a plus b squared, which is a squared plus 2ab plus b squared, which expands to, so 3x squared, so 3x squared is going to be 9x squared, plus 2ab, so 2 times 3x times 1, which is 2 times 3x essentially, which is 6x. 1 squared is 1. So this is your a squared plus 2ab plus b squared. And then plus 3, that's just the constant value we got from the original function. So plus 3. Now, since you have no other like terms for x squared than x, you leave them. But you have for the constants, you have 1 and 3. So 1 plus 3 is 4. So this is your final answer, 9x squared plus 6x plus 4. Okay, see. F inverse of 57. So for this one, you're going to want to find the inverse function of f of x. Then substitute 57 into that function. So we start off by swapping f of x with y. Y equals to x plus 1. Now you solve for x. So take 2x to the other side and take y to the other side. And then you'll get 2x equals y minus 1. Then divide by 2 on both sides to cancel out the 2 here and just get your final x, which is x equals y minus 1 over 2. Okay, now you want to interchange x with y and then put y as f of x. So what this would mean that y, I skipped this step on a copy because like we did this multiple times. This would mean y equals x minus 1 over 2. And then you substitute f of negative 1 of x for y. So f negative 1 of x equals to x minus 1 over 2. Let me change the color, this isn't clear. Okay, there we go. And I'll just change the thickness so you guys can see better. So this is our final function, which I also wrote here. Now we substitute 57 into this final function. So f of negative 1 of 57. 57 minus 1 is 56. 56 over 2 is 28, and 28 is your final answer. Okay, part D, which is f of x equals to 17 for x equals what? Basically, what this means is you have f of x is equal to 17. What is the value of x? So you know how a function is, for example, f of x, whatever the function is, whatever, I'll just write dots. What this means, they gave you the value of f of x. So like basically this is y, this is your f of x value. 17 equals your function. And in our case, f of x was 2x plus 1, so 17 equals 2x plus 1. Take the 1 to the other side, 2x equals to 16. And x equals to 8. That's your final answer. Okay, part E. This is the one that's going to be dealing with exponents. So you're going to need a calculator here to 3 significant figures, h of 0.8 equals. So we have h of x is equal to 3 to the power of x. So just substitute 0.8, h to the of 0.8 is equal to 3 to the power of 0.8. So now you just do this on a calculator. So I have the calculator here. There we go. Okay. 3, and then to get the exponent, this button here, 0.8 equals 2.408, but they wanted to 3 significant figures, so you round 2.408 to 2.41, and that's your final answer. We're here. We reached part F. So 2187 equals to 3 to the power of x. right? Now, if your calculator is an equation solver, you can just do 3 to the power of x is equal to 2187. Now shift calc equals, and you'll get x equals to 7, which is our final answer. But some calculators don't have an equation solver, so you're gonna need to do this by hand, which is really annoying. بس يلا whatever. So to do this by hand, you're gonna need to know something called the natural log or ln. Uh, I don't have time to go into what it is. Basically, all you need to do is write an ln around both of these. So ln 3x and ln 2187. I can't write it around it. So it's this step here. Now, by our natural log rules, which we didn't take to be fair, the exponent becomes a coefficient. So you take this out of the bracket and put it here. So it becomes x ln 3 equals to ln 2187. Okay. Now, to find x, you're going to want to divide by ln3. That's it. There we go. Okay. On both sides. Now, ln3 here cancels with ln3 at the bottom. So x equals ln 2187 over ln3. Which is, we'll just do it, ln 2187 over ln3 equals 7, and 7 is your final answer. Now, only do this if your calculator doesn't have an equation solver. I know this is going to take way more time, and we didn't even take this, to be fair. But I think the school expects you to have an equation solver, because we generally didn't take this, so it's fine. Okay, moving on to question 2. I cut it again. I'm going to re-explain question 2. So cosine theta, or sorry, tangent of theta, tan theta is equal to sine theta over cosine theta. So cosine theta. Now, another way to memorize tangent is SOHCAHTOA, which I explained last year in one of the CE videos. So SOHCA, that's whatever. SOHCAHTOA. Now all you have to memorize is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, if you think about it, opposite over adjacent is because it was originally sine over cosine, but the hypotenuse values cancel out, so which I'll demonstrate here. So we'll explain it to you. Tan theta is equal to 8 over 17 over 15 over 17, right? So now these two values cancel out. The 17 and 17 cancel out, which makes it essentially 8 over 15, which is our answer. Now, if you think about it, this is why tangent is opposite over adjacent, because the hypotenuse values, it cancel out in general. So this is all you have to know. 8 over 15 is our answer. And moving on to question 3. Okay. Question 3. Okay, cosecant. What's the value of cosecant theta if cosine theta is 15 over 17 and sine theta is 8 over 17? Now, cosecant of theta, so CSC theta, theta is equal to 1 over sine theta. Okay, so now all you have to do is cosecant theta is equal to 1 over 8 over 17. Now, you can do it the way I did it in the notes, which is keep, change, flip. And then you get 1 times 17 over 8. Or, once it's a reciprocal, so like 1 over whatever, 1 over x, the value is going to be 1 times x over 1. So your value is going to be x. So when you have 1 over something, it's the reciprocal of it. It's the opposite. So if we have here 8 over 17, so 1 over 8 over 17, I'm just going to write it here because this isn't clear. 8 over 17. This flips to be 17 over 8. That's the reciprocal. But you can do keep change flip. So keep 1, change the multiplication, the division to multiplication, and flip 17 over 8, or 8 over 17 to 17 over 8, which gives you 17 over 8. So question 4. Secant theta is base is 1 over cosine theta. So secant theta is equal to 1 over cosine theta. So just apply it. So secant of theta is 1 over 15 over 17, which again is the reciprocal. So 17 over 15, and that's your answer. Okay. Question 5. What's the value of cotangent theta of cosine theta, whatever? Okay, these are all the same values. Cotangent of theta, or cot theta, is equal to cosine over sine. So cosine theta over sine theta. You should remember that the tangent is sine over cosine, so the cotangent is the opposite. It's the cosine over the sine. Okay, so cotangent of theta is equal to this, right? So now what you're gonna want to do, write that down. Write cotangent of theta is equal to 15 over 17 over 8 over 17. Again, the 17s cancel out, so you're gonna be left with 15 over 8. Okay, so this is cotangent theta. Now, if you remember, tangent was opposite over adjacent. That's why it's the TOA part of SOHCAHTOA. So now cotangent is adjacent over opposite. That's just an easy way to memorize it if they give you a triangle, which they won't, but يعني, they might. It's Sabis. 15 over 8 is our answer. يلا, question 6. Okay. 2 pi radians equals to what degrees? Now, there's multiple ways of knowing this. First of all, you can memorize pi radians equals to 180 degrees. And then you can derive. So, like, for example, you can derive the conversion factor. So let's divide by pi on both sides. 1 radian equals to 180 over pi degrees. Now you can also do the other way around. Divide by 180 on both sides. So you're gonna get 1 degree is equal to 180, or pi over 180, sorry, pi over 180 radians. Okay. And you can also memorize the decimal value, the approximate decimal value. You can know that 1 radian equals to 57.3 degrees. Now, I recommend using this conversion factor because it generates approximate values. Keep in mind, it generates approximate values. So, يعني, for example, it's not gonna, if I did 2 pi times 57.3, it's not gonna give me 360 exactly. It's gonna give me 360 point something. But it's much quicker on a calculator than writing pi over 180 or 180 over pi, whatever you want to do. So I'll just do 2 pi, so 2 shift times 10 to the power of x into 57.3. So 0.3, which equals 360.026, whatever. It's approximate value, but you only take the whole number. So I would always recommend using this one, except when, for example, your degree value was, for example, like 249.9 or 0.49. Let's take 49 because 249.98, take it as 250, for example. 250 point, like 249.49. This is when I would recommend using the fraction for the conversion value, because that will generate a more precise result. But if they give you like 250, if you multiply 57.3 by whatever, it gives you 250.6. خلاص, take round it up. Or يعني, you get the point. So that's how you memorize that. And by the way, there's going to be a lot more questions in this quiz about radians and degrees, so we'll practice. Now, 5 over 6 pi radians is equal to what degrees? So we know that 1 radian is equal to 57.3 degrees. So you're going to multiply both sides by 5 pi over 6 to get 5 pi over 6 radians, or 5 over 6 pi, whatever, is equal to 5 over 6 pi times 57.3. So you do this on a calculator. 5 over 6 pi. So shift by e alpha. No, you don't need to do that. Never mind. Brackets 57.3. Close the bracket. You get 150.011. See what I mean? It's gonna give you approximate values, but it's values that are good enough to pass. So like 150. Just take it as 150. So yeah, 150.011. That's it. Now on to question 8. Now, kid, you can use it. You can use the fraction way. So again, just to remember the derivation, pi radians. That's a plus. I'll denote radians by r, but it's not. Take it as rd in written. 180 degrees. So then 1 radian would be 180 over pi degrees, which is by the way, it's like 57.299 something. So let me just do it. 180 divided by pi. So shift percent power of x. 57.295. You can either save this as a constant value in your calculator and use it straight away without changing the fractions, and then you'll get the precise result, or you can just use 57.3. It's good enough. So then you want to multiply these values. So back to this. Multiply 1 radian by 5 over 6 and multiply this by 1 over 5 over 6 pi. So let's just do that. Just to show you, yeah. So 5 over 6 pi brackets 180 over pi, which I already did the fraction. 180 over pi. Close the bracket. You're gonna get 150 exact. So see, it gives a more precise result, but it's more time consuming. I wouldn't recommend it بصراحة. Question 8. What whole number must replace the question mark and 40 degrees? I'll replace the question mark with x. 40 degrees equals to x over 9 pi radians. Okay, so what you're gonna want to do here is multiply it by the conversion factor. So you know that 1 degree is pi over 180 radians. So you're gonna multiply this value, the degree value by 40, and this whole value by 40, which is gonna give you. So let's do it. 40 brackets pi over 180 quiz 2 over 9 pi. So that's our answer. They only want 2. Now question 9. 2 over 3 pi radians is equal to how many degrees? So 2 over 3 pi radians is equal to 57.3 times 2 over 3 pi degrees. So 2 over 3 pi 57 point. If you want to memorize 57.295, by the way, you can. Like, it will give you a more precise answer, but take it as 57.3. It's fine. So what you're gonna want to do now is 2 over 3 pi into 57.3, which is 180 over pi at the same time. 120.0088, so just take it as 120. And question 10. What's the value of m if cotangent 27 degrees is equal to tangent m degrees? Okay, Um, like cosine and sine. Uh, Never mind. Uh, Cotangent. So cotangent theta is equal to tangent 90 minus theta. Okay, you can do this method only if it's given that it's between 0 and 90. That's why they gave this, so you can apply this. Or you can do cotangent is 1 over tangent, but it's going to be much harder, and it's practically impossible without a calculator with an equation solver. So we're going to use this method. Cotangent 27 is equal to the tangent of 90 minus 27. Okay, so cotangent of 27 is equal to the tangent of 90 minus the 27, which I already wrote, which is gonna be 63. So tan 63. And m is m tan m, so 63 is our final answer. Okay, question 11. What's the value of cosine theta? This is where you apply SOHCAHTOA. SOHCAHTOA. There you go. So I'm gonna go to the notes for this one because I already wrote the triangle down on the notes. And by the way, for this question, I also wrote what I said between if it's 0 and 90, then you apply these. But this is for question 12, so we're not here yet. Okay, question 10, here we go. 11. I draw the triangle? I swear I did. Whatever. I'd probably do it on another question. Okay. So cosine theta against SOHCAHTOA. So cosine is the k part, so I'll just write it down. So adjacent, so cosine equals to adjacent over hypotenuse. Okay, so the adjacent of theta is this line 40, and our hypotenuse is the longest side, which is 41. So this is our final answer. You can't simplify this any further. So it's 40 over 41. Okay. Question 12. Fill in the blank with whole numbers representing measures of acute angles. An acute angle is an angle between 0 and 90. That's basically what an acute angle is. It's the same application as question 10 with the cotangent and the tangent, but this time so the sine and cosine. So cosine theta is equal to sine 90 minus theta, and sine theta is equal to cosine 90 minus theta. I think your teacher should have explained this. So we go here. Cosine 26 is sine 90 minus 26, which is going to give you 64. And sine 49 is equal to cosine 90 minus 49, which is 41 plus 49 gives 90. It's more in depth on the notes. So not really that much in depth. يعني cosine 26 equal to 90 minus 26 sine 64. It's just what I said, but I wrote it down. So question 13. Given triangle, this is where I drew my this is where I did it. So I'm gonna take it so I can draw the triangles. Okay. Given triangle ABC is right, so we'll draw a right triangle. Just assume this is right, whatever. With AB as 11, BC as 60, and AC as 61. So obviously AC 61, that means our longest side is 61. And this is AC here, making this B. So AB is 11, that's an 8. AB is 11, BC is 60, AC is 61. Okay. Cosine of A. Again, cosine is adjacent over hypotenuse, so the adjacent of it is 11, and the hypotenuse is 61. Now, can you simplify this any further? No, you can't, and 11 over 61 is your final answer. Okay, question 14. Given ABC is the right triangle, same given, but this time it's sine alpha. It's sine A, not alpha. That's physics. Sine A would be, so this, I'll just write this as cosine. And the sine of A is equal to opposite, because so of the so part of SOHCAHTOA. So is opposite over hypotenuse, which is 61. So 60 over 61, which you cannot simplify anymore. And this is your final answer for the sine. Now, question 15. What's the value of the tangent? Okay, the tangent of A is again sine over cosine. I'm gonna apply it to sine over cosine because just as an extra practice on the way that the book does it. So 11 over 61, or 60 over 61, sorry. 60 over 61 over 11 over 61. Now 61 and 61 cancel, so it's 60 over 11. Kids, you can do opposite over adjacent, but I'm doing this for extra practice. So 60 over 11, and that's your final answer. Question 16, which is the final question. This is about how do you find the frequency given the histogram and the history and the frequency density. Okay, so we go down to question 16. Now, the frequency density is the frequency of D is equal to the frequency by the width. So the frequency is equal to the width times the frequency density. Okay, so now to find the frequency of the first one, F1, we'll say. The frequency of the first one is equal to 2 times the width. So this is 0 here, obviously. So 2 times the width, which is 4. 2 times 4, which is 8. F2 is equal to 4 to 6. So this is our width. You take it, Akid, from this. You take it from these values down. 4 to 6 is this. So our width is 2. Times the frequency density, which is 6. So 2 times 6, which is 12. And now for F3, again, the width is 2, 6 to 8. And the frequency density is 8. So 2 times 8, which is 16. F4 is 8 to 9 this time, which is 4. So 1 times 4, so 4. And F5, I'm just going to bring this slightly up. F5 is equal to 9 to 10. I'll just erase this circle. 9 to 10, which is 1. That's our width, times the frequency density, which is 2. So 1 times 2, which is 2. Perfect. Okay, this is our, these are our frequencies. Now, just to make sure, you add all of them up on a calculator. If they should equal the number of how many students they gave you. So here they gave you 42 grade 10 students. So it has to, the total number has to equal 42. Now, if we add all of them, let's check. 8 plus 12 plus 16 plus 4 plus 2, which is 6. I'll just summarize 6, and we got 42, and that's correct. So that means our frequencies are correct. Okay, that was the final question in the quiz. Good luck, guys. I'll see you soon.